Good morning, afternoon, evening. This is Mr. Precella, and I'm working with my Math 1332 class. And today we begin our discussion of logic, and hopefully you've had a chance to read in your textbook the assigned reading and watch the Pearson video. And I'm going to start working through the homework problems with you, so you have some homework examples to look at. And let's see, first of all, this first question, you will find the store at the first set of lights. Is the given sentence a statement? Well, what the heck is a statement? Did y'all get this from your reading? Statements can be assigned a truth value. That is, a statement is either true or false. This first one. You will find the store at the first set of lights. Well, that statement is can be it's either true or false. You can look at that, first set of lights and see, is there a store there or not? So this first sentence here is, yes, it is a statement. Hold this for me. Now that's just a command. It's certainly not a true false statement. You could decide it didn't say Tom held the book for John or something like that. In which case, then yes, that's either true or false. But this one here, no, it's not a statement. The same thing, do you believe in ghosts? Well, that's not something that you say true or false to. Okay, so generally questions are not statements. Okay, so is this statement? No. Let's see. Cassie is waiting for her friend. Now that is either true or false. Maybe Cassie's shopping for groceries, in which case she's not waiting for her friend or something. But is Cassie waiting for her friend? If she is, then true. If she isn't, then false. So this one is a statement. Here's another question. Do you like pistachios? That's not a statement that can be assigned, or that can't be assigned a true or false value there. Okay. If it is that John likes pistachios, then you can ask John, do you like pistachios? Is that true or false? But do you like pistachios is not a statement. Now, let's see. The chapter in this book is called, this first chapter, Statements, Connectives, and Quantifiers. Problem number 6 looks like it deals with connectives. Okay? Examine the statement to identify which connectives are being used. And here's the statement. If you want friends, you must be positive and have a sense of humor. I think Pearson left out. Have a sense of humor, a positive outlook, or be helpful. Well, there's several connectives going on here. There's and, or, and also this if. If you want friends, there's the understood word then. In math, we always talk about if-then statements. Here the then isn't stated, but it's a if, or, and, let's see, and. Notice this last statement. The statement is simple, so there's no connectives. If there's no connectives in it, then it's a simple statement. Did y'all get that from your reading? Now, let's see, what about number 7? It says, identify the statement as simple or compound. Again, if it's simple, it means that there's no connectives. If the statement is compound, identify the connectives. Peter or Adam will train a pet monkey. Well, there's that or in here. So this is a compound statement. And, ooh, it's getting sort of low. Can y'all see that? Or is the connective that's being used there. Simple statements have no connectives. The connectives that you'll see are or, if, then, and, if and only if. Must is not a connective. Okay. Number 8. Same type of problem. Decide if it's simple or compound. If it's compound, identify the connectives. Joanna likes playing music. There's no and, or, if. This is simple. So no connectives. Number 9 is another one like this. Examine the statement and identify which connectives are being used. Okay. If I like comedies and I like dramas, then I will like the movie. Well, I noticed there's an if-then as well as an and on in here. Okay. There's an if-then and an and. Okay. Where and allowed aren't even there, but they're not connectives. Those are verbs. Okay. Are y'all caught up with me? I'm going through this pretty quickly. Simple statements have no connectives. Compound statements have connectives like and, or, if, then. Let's see. This is problem number 10. Indicate whether the statement is simple or compound. If it is compound, indicate whether it is a negation, conjunction, negation. A conjunction is and. This little carrot top symbol here means and. Disjunction is an or. Conditional is if then. Biconditional would be if and only if. So let's see. If the game is not sold out, then we must get tickets. Well, it's not a simple statement because there's that if then. That's a compound statement. Oh, pardon me. And which one of these is the if then? Well, that's the conditional. Okay? If the game is not sold out, then we can get tickets. You see, there's that condition. Can't get the tickets if the game's sold out. Okay? It's not a negation. It's not a or. It's not a if and only if, and it's not a and. So we have the words negation, disjunction, conditional, biconditional, conjunction. Hopefully you saw those words in your reading. Again, watching me do these works so much better. I think you get more out of them if you have a chance to read through the book and to watch the videos that's assigned there before this, before you see me just working out the problems. Now, let's see, number 11. We're going to start using variables to stand for statements and then start writing this out in symbolic form. It says, if P stands for this meal is delicious, and Q stands for busy people do not eat, write the following in symbolic form. Okay, so busy people, so P is the meal is delicious. Q, busy people do not eat. So let's see. Busy people do not eat, that's Q. And, so up here at top, this meal is not delicious. Well, that's a negation. See? P is the meal is delicious, so this meal is not delicious would be not P. So we're looking for Q and not P. Which one is that? It is A. Can y'all see this pink ink here? Maybe I should use a darker color. Okay. On B, this meal is delicious. That's P. Or, you write or with the V-shaped figure. Okay? There's those symbols here. This is the or, this is the and, if and only if then, and that negation is not. So this meal is delicious, that's P, or this meal is not delicious, that would be not P. So P or not P, is that going to be B here? Can y'all see that better in blue ink? Now, C. Now that one's a little tricky. It is false that. It is false that. It is false means not. You're negating. It is false that both this meal is delicious, P, and busy people do not eat, Q. So it is false that, so you're negating this. This meal is delicious, P, and busy people do not eat. So which one is that? That is A. Okay. See if we have another one like that. Now, let's see, what's number 12? Let's see, it says, write the statement in symbolic form. Oh, here it's not going to be multiple choice. I know when I just have these problems printed out, so it looks sort of intimidating, but it's pull-down menus that you're going to be using. P is the statement, Clarice will wear pink. Q is the statement, Sharon wears pink. We want to write this statement symbolically. Clarice will wear pink tonight. That's P. If and only if, you see, this is P. If and only if is that biconditional denoted with the double-headed arrow. Sharon does not wear pink. Well, Q is Sharon wears pink, so we need to negate that. So you're going to pull down P, if and only if, not Q. Any questions there? It's a nice little introduction to logic. Writing these statements that can be assigned, a statement can be assigned a truth value, either true or false, we're writing it symbolically. Let's see. Number 13 says, consider the statement. P is the belt is black, Q, the scarf is brown. Let's write this statement not P or not Q. Okay? In English, okay? So if you know other languages, don't write it in those other languages. Write it out in English. Okay, not P would be the belt. If P is the belt is black, not P would be the belt is not black. This little V-shaped figure here is or. Not Q. Q is the scarf is brown, so not Q would be the scarf is not brown. So let's see, which one is this? Is it C? Yeah, C. Okay. There's another one. We're told what P is job pays well, Q the stove is hot, R the chair is broken. So we're going to write this out in words. This little symbol here with the arrow one way is the if then. So it's if R, that's the chair is broken, then, that's the if then, okay? Q or not P. Then the stove is hot. What's that little V mean? It means or, not P. P is the job pays well, so not P would be the job does not pay well. If the chair is broken, then the stove is hot or the job does not pay well. Let's see. Which one is that? C. If the chair is broken, then the stove is hot or the job does not pay well. C it is. Now let's see. Number 15 says to negate this statement. Now, when y'all were reading in your book, did y'all see this little diagram? All, some, none are, at least one is not. Oh, let me move. Oh, thanks. These arrows are showing you the negation. The negation of all are is at least one is not. Okay? The negation of some are is none are. Okay? And that goes both ways there. The negation of none is some. The negation of at least one is all. So we're going to negate this statement. All dodo birds fly. Well, do you see how to use this statement here? The negation of all is at least one. Dodo bird does not fly. Okay. Or let's see how they word it. They say there exists at least one dodo bird that does not fly. So that is A. Number 16. We'll use this. So we're negating statements that involve the words all, some, none, at least one. Okay? Negate this statement. Some dogs are rabbits. Well, if we're going to negate that, that would be none are rabbits. I'll write it like this. No dogs are rabbits. No dogs are rabbits. That was this one right here. Oh, I'm going sort of quickly. Are there any questions? Are you following this? This little diagram here is very important. To negate an all, that would mean at least one is not. To negate a some are, that would mean none are, and vice versa. To negate none, you say some are. To negate at least one, you say at least one is not, you say all are. Ooh, what is all of this? Looks like we're going to get to practice some of our logic. Looking at this table. Use the following table of student information to determine whether the given statement is true or false. If a statement is false, explain why it is false using the rules for quantifiers that we have developed. So the statement is all sophomores are athletes. Let's look and see. See, here's this athlete column. Let's find every sophomore. Well, it looks like Tito's not an athlete. Piers is an athlete. Tim is not an athlete. So is this statement true? Are all sophomores athletes? Well, no. In fact, here are two of them that are not. Okay? The negation of all would be at least one. Did we have at least one sophomore that is not a athlete? Yes, we have two. So which one is this? This statement is false. Let's see.
B.
No, B. It's Tito and Tim that are not athletes. B. Let's do another one like that. Hopefully this is letting you see why this statement here, this little diagram, why am I saying the negation of all are is at least one. We had to find at least one of these sophomores that was not an athlete, and then this statement's false. So what about this one here? Same type of table. And it says, there exists a junior who is a commuter. Let's look at all, so we're looking at the commuter columns. Okay, junior. Well, this Omarosa is a junior. He's not a commuter. Is there another junior that's a commuter?
John and Stephen.
Let's see. There's all the juniors. Omarosa, John, and Stephen. None of those are commuters. So what will we say about this statement here? There exists a junior who is a commuter. Well, that statement's false. Why? Because Tito is not a commuter? Why is this statement false? There exists a junior who is a commuter. The statement is false because no juniors are commuters. There's not a single junior that's a commuter. So the statement there exists a junior who is a commuter is false. All the juniors are not commuters. None of the juniors are commuters. You look at each one of them. First time I brought this out, I printed it out on black and white ink, and I was like, what is this? So you got to have this one in color, else just be looking at your computer screen to answer this one. It says, consider the happy and sad faces to the right. Decide whether the given statement is true or false. If it's false, state its negation clearly. And so here it is. Some yellow faces are in blue boxes. Are there any yellow faces in blue boxes? Here are the yellow faces.
No, that's not a yellow.
Wait, these aren't yellow faces. Here, here, and here. There are 3 yellow faces. Some yellow faces are in blue boxes. Is this true or false? Oh, and now I notice it tells you the letters here. The box is green, the face is yellow. When I just printed this out all in black and white, I didn't even notice that. So it tells you. So it would have been, I shouldn't have immediately said, uh-oh. So it sort of helps you out. So this is false, isn't it? No yellow faces are in blue boxes. There's not a single yellow face in blue boxes. So which one is it? It's false. We're then told to state the negation. No yellow faces in a blue box.
C.
So this one is C. So hopefully these last few problems gave you a chance to sort of practice using your logic skills. Okay? The way you use and or is very important, along with some, all, none, at least one, and so forth. So this was our first section over logic, and hopefully you've had your chance to read in your book and watch the video. Now work on your problems, okay? Thank you for listening. Bye-bye.